try another example. So I want to compute a vector line integral with C is, describe that thing.
Is it half
Half a circle.
It's half a unit circle.
But it's going.
It's clock.
Looks like it's going
Clockwise?
counterclockwise.
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 So I got half a unit circle counterclockwise.
So
Is that it?
I'm confused with that. What's the bottom though?
Yeah, and also that bit.
Would that have to be piecewise then?
Yeah, I'm gonna have to piecewise this.
Oh.
So I've got a half a circle and this cut across. If I just do the half a circle, right, that's only gonna tell me about from here to this side.
Oh, okay.
I won't learn about going back.
So two separate intervals?
Yeah, so I'm gonna need two separate integrals. You guys cool with that?
Yeah.
And then I've got a vector field that's f is minus y comma x. You guys remember what that one looked like?
That's the eddy, right?
Yeah, that was the eddy. So what's going to happen if I think about what value I expect to get out of a kind of eddy with this thing?
It should be good.
Yeah, it's a plot. It's flat.
Yeah,
It's
the
going to
top
help me
part.
across the top part, and then across the middle, it's spinning.
It'd be kind of hard.
Yeah, it can be negative most likely.
Or
On the
no,
outside,
it's
it's
not
really
existing.
hard, but on the inside.
It should be 0 there.
Yeah, it should be 0 there. Because you're going cross current, right? Current's not helping you, it's not fighting you.
Okay.
You guys see that?
Yeah.
It's just kind of pushing along in a perpendicular direction.
So does that mean we don't even need to do that bottom part?
Yeah, we could notice that this piece is going to be 0. Let's see that. But yeah, that bottom piece is going to be 0.
Okay.
So that's not going to cost me, but it's also not going to help me through there. And it is going to help me across the top. So I expect to get something positive out of this. You guys cool?
Yeah.
All right, so what do I need to start with?
Well, parameterization. Right?
Yeah, I need a parameterization, but there's two curves, right?
Well, one of them is just I, isn't it?
Let me call it red curve across the top,
Because
blue curve through the bottom. And so I want to calculate, I should add another symbol to this. Let me add this little symbol.
what does that stand
Intuitively, what should that stand for? I added a little circle to the integral sign.
Two curves or piece right?
How about it's a loop? You guys see that? If I think about this,
Oh, you're going back to where you started.
starting here, I'm going around, coming back to where I start. Does that mean there's a starting point?
for?
Not really, right? Because I could just as easily think about starting
Oh
over
yeah,
here.
because you just keep going the same place.
You guys see that?
Yeah.
So there's going to be something a little funny on this one. You're going to get to pick the starting point too. And all this little guy means is that it's a closed path. It's just a loop that comes back to
So
it.
it'd probably be easiest to start on the right, or else you'd have to do like 1, 2, 3.
Good, yeah. It's probably going to be easiest for me to start over here. Right? Because I know that top thing. And then the bottom will be pretty easy. Over here would also be an okay start. Right? Because I know this bit and then that bit's okay. But like midway through here, probably a crappy spot to pick. Halfway through the circle, even worse. Right? So I'm going to start by writing, all right, I've got the integral over a closed curve C of f dotted with dr. And we're going to make that into what?
From 0 to pi.
Okay, which piece is that? Is that red or blue?
It's red.
Red? Okay, so you're going to go red from 0 to pi.
Cosine, sine.
F of sine, of cosine.
F of cosine theta comma sine theta. Dotted with
Negative sine theta.
negative sine theta comma
Cosine theta.
cosine theta.
Theta.
Okay, so hang on. This was me really thinking r of theta for red is cosine theta comma sine theta.
Yeah.
Okay, good. And then you're doing d
Theta.
theta here. Okay, so that's the red bit. Good.
And add.
And the
Oh, yeah.
blue bit is going to be plus
Integral from
integral from
Um,
-1 to 1.
yeah. Yeah.
Good. -1 to 1 of f of, what's your parameterization here?
That is why it's, t.
It would just be-
Theta and 0, or t,
Yeah, t and 0.
theta.
Okay. You want to parameterize r of t, right? Which is going to be t comma 0.
Yeah.
Does that go where you expect it to go? I need that way, right?
Yeah.
One
It
to
is.
go.
So is this end t is -1?
Yes.
Yeah.
Yep. Is that end t is +1?
Yep.
Yeah.
Yep. And is it that line?
Yeah.
Yep. Okay. So I need f of t and 0 dot product with
One,
With 1, 0.
1, 0
times
times dt. Okay, you guys notice I got two variables of integration?
but you're gonna end up with
But they're just dummies, right? This is going to give me a scalar, that's going to give me a scalar. I can add scalars together. Totally fine.
Yeah.
Do remember your limits of integration, otherwise you'll end up with really screwy things like a function of theta plus a function of t. Alright, what do you get out of red? You get the,
So the integral is 0 to pi.
okay, integral from 0 to pi,
Negative sine theta.
negative sine theta, I think,
Cosine theta.
comma cosine theta.
Dotted with negative.
Does that make sense?
oh, because we're doing x, y, further flip.
Yeah, so I was going to put in this for x, right?
No, oh, okay.
And this for y.
Gotcha.
So it goes minus y in the first coordinate, so minus sine theta, and x in the second coordinate.
I think
cosine
it's
theta.
becoming 1 theta. 1 t theta.
Yeah, of course. It's easy. Okay, and then I got here minus sine theta, comma cosine theta, d
T theta.
theta. Right, this one's in theta. And Donald noticed that this is 1,
Yeah,
but
that's good.
let's do the other half and then we'll finish that.
Okay.
So on the other half, what have I got?
You get
Got the integral from -1 to 1,
0 t. Dotted.
0 t
No, one.
dotted with 1, 0
But that ends up becoming 0
t. And this one's easy to notice, right? These vectors are perpendicular. What's that about?
That just means that
Equals 0.
the dot product is 0.
Yeah, that's a product of the flows perpendicular to the motion, right? So of course the flow is not helping you, but it's not hurting you either. So this piece zeroes out. And all I'm left with then is red. So I get equals,
So you just get pi.
Yeah.
yeah, and then we could notice that this dot product is sine squared plus cosine squared, so I get 1. So all that jazz is 1. So I got the integral from 0 to pi of 1 d theta
Which equals pi.
gives you pi.
And so you're not wasting any effort going through the flow.
Yeah. Please notice, right? If I was asking you a question about getting from here to here in a vector field F,
It's 2 pieces.
if you went this way or that way,
Wouldn't you subtract the second
right?
portion?
Like if this was path 1 and this was path 2, yeah, I'd do P1 minus P2 to do the loop, right? You guys see that? But what does this mean in terms of swimming in this vector field F? I just learned that the top piece was
The top piece.
pi, right?
No.
That's the argument.
And the bottom piece was 0. You guys see that?
Oh,
Yeah.
no, that is the arc.
And it happens to be the arc length because F has unit speed in that direction. But the bottom piece was 0, right? So if
Yeah.
I go the other way on it, I also get 0.
Yeah.
You guys see that? So the integral over P2 of F here dot dr is 0. The integral here over T1 of f dotted with dr
So it'd still be pi.
Still
is
be pi.
pi. You see that? These are not independent of path. Right? It matters which way you swim on this flow. You guys see that?
Yeah.
This isn't true in all flows, but in some flows, it matters which way you swim.
Would it be kind of like the vector when if you went the other direction, it'd just be minus pi?
Yeah, so if I went the other way, it'd be minus pi, right? I'm going to
Okay.
swim against the current, and 0 in the other direction, right? But the thing I want to drive home is that it matters which path you pick. So it's not enough to know that you want to go from point A to point B. You have to know how you want to go from point A to point B. Cool? Does that make sense? So although which parameterization you pick doesn't matter, which path you pick does.
Okay.
You guys cool with that?